Alright, today we are working with the stack magazine station. So the purpose of this station, we can load a magazine of parts, or these little lids, into the magazine, and it holds a total of 5. And we can put the base here, and we can use the station to press the lid on the base and then eject it. So in order for that to happen, we're going to extend this cylinder, which will push out one of the parts onto the base. We will retract this cylinder. We will press these together. I've got my air off so I can move these freely. We'll press these together and we'll hold them together for 5 seconds to let the glue dry. And then we will eject it using the cylinder at the bottom. Now, that is an optional step for this particular lab, but it is the more realistic and more complex application, so I want to show you that anyway. So, the elements of this station, besides the 3 cylinders that we already showed, and that one's back here, I can't pull it out, but beyond those are, of course, the directional control valves, which actually control the motion of the cylinders themselves. So, terrible. So those directional control valves are up here, and each one of those is actually a 4-2 directional control valve, meaning that it has 4 ports and 2 positions. So we're going to be looking at these as digital actuators because they'll be in one position or the other. And using our air, we can, if our air is on, it's not, we can press these little overrides to check which one of our ports is going to control which motion of the cylinders. So, let's check my center here. That's not too bad. So, in addition to those, we have some little magnetic sensors on each of these cylinders to help us figure out what position they're in. So the way those work is basically there's a little magnet on this and it detects the plunger inside of the cylinder itself. So you do have to work with these a little bit just to get them calibrated and positioned exactly right, but I've already fiddled with this one, so it's in good shape. And finally, today we will be doing this with the FluidSIM, and we will be doing this with the EasyPort Mini. I will also be posting a video later on, including doing this on a PLC, but it's not what we're doing today, so there you go. So finally, you will see when I code through this that each one of these is a little flow control valve. They're harder to see on this one down here, but they do exist. So I will be including those in my schematic. Yes, your schematic will work perfectly fine without them, but they are on the physical system and I want my schematic to reflect the physical system. So we're going to do the best we can. First of all, I want to put together my pneumatic system. So I can close up all of my electronics for the moment. And I'm going to come up here to pneumatic. I'm going to open up actuators, and on my system I see that I have 1 single acting cylinder. That means it has 1 inlet port, and I have 2 double acting cylinders. That means they have 2 inlet ports. That means that on the single acting cylinder, if we turn off the air, it's going to go back to its normal position. With the double acting cylinder, we have to actually move the directional control valve. We have to actually move the valve itself in order to command it to go back the other way. Now on our system we have a variety of these. So we have a single acting cylinder that is driven by a 4-2 directional control valve that has spring return, and it has, while it has 4 ports, we've got 1 of those capped off. You put these in here. Try to keep this as compact as possible because this gets full fast. And
We need our directional control valves. And while I have a series of these already available, if I look through them, I'm going to realize that the ones that are actually on my station are not available here. So we're going to go to configurable. We're going to find the 4-in way because we have 4 ports, and we're going to go with 2-way valves. So I'm going to pull that in, and I'm going to need 3 of these. I'm going to go ahead and connect ports 4 and 2. Those are going to be my outlets, and those are going to go to my cylinders. And now I'll configure those in just a second. I'm just getting the basics in here. I need a supply, so I'm going to need compressed air. My compressed air always goes on port 1. That's always my inlet. So the convention is my inlet is always number 1. My even numbers are going to be my actuating ports, or the things that can actually do work. And then all my odds are going to be on the bottom here, and anything that besides 1 that's an odd number is going to be an exhaust. So on all 3 of these, we're going to click on this, go terminator, and we're going to put an exhaust on those. Right. I'm going to label each of my cylinders. And I want to configure these valves. So if I click on these, double click, I'm going to see configure valve over here. I'm going to go in here. I have several options here, but the valves that we're using are electrically actuated and manual override. They are also piloted, and they have, let's see, this one is a spring return. Okay, now we see we have one actuating port, one electronic port that I can connect to this and command it. The one for cylinder 3 is going to be exactly the same, except that those ports are connected up to it. So piloted, manual override, and a spring return. Should have mentioned that this one, since we don't have anything here, we're going to terminate that with T. So that's basically just caps it off, and if you look on the physical system, that's exactly what we've done. Now, finally, for the one in the middle, the double acting cylinder with the 2-way directional control valve. It's going to be electrically actuated and piloted on each side. And each one has a manual override. Alright, so we can see that all of those symbols now show up. Next, anyway, we need our flow control valves. And for this, we are going to use our throttle check valves. These are going to limit the flow rate into our cylinders. And each one of those is going to be identified by the cylinder number and V for valve and the valve number. So 1V1, 2V1, V2, V1, cool. Now we have our pneumatic cylinders.
So once we have our pneumatic cylinders defined, we can move to the electronic schematic. I'll start by placing a 24-volt source and a 0-volt ground. I'll also add valve solenoids, and I will label those for each one of my electropneumatic cylinder outputs. To start the logic, I'll add a relay coil and a contactor and a manual start switch. I'll use the contactor to activate 1M2, which will extend my plunger and eject a part from the magazine. I'll then check the code to verify that I get the physical behavior that I'm expecting. The next step is to retract the plunger 2 seconds after it reaches its fully extended position. I'm going to use the sensor attached to the cylinder to do that. I'll use the signal from the sensor to activate a 2-second on-delay timer, which will then activate 2M2 and retract the plunger. Once that's completed, I'll again verify that I get the physical behavior that I'm expecting. The next stage is to extend cylinder 2A to press the lid and the base together and hold them for 5 seconds to set the glue. To do this, I'll add an off-delay timer, which is triggered by the on-delay timer from the previous step, and I'll set this for 5 seconds. Now, recognize that this does mean that our cylinder 2A is going to extend as soon as the magazine starts retracting, but that's perfectly okay since these two pieces of the system don't interact. And again, once I'm finished with this stage of the operation, I'm going to check all of my logic to make sure that I'm getting the behavior that I expect. And at this point, I want to point out that this is all of the behavior that I expected in the original lab assignment, but I am going to continue on and show you the rest of the solution, including the third cylinder. Adding the action of the third cylinder, the eject cylinder, is a bit more difficult than it would initially appear, especially if you want the proper behavior. The simplest solution, which is nearly correct, involves adding a third timer, an on-delay timer set for just barely shorter than timer 2, triggered by timer 2, and then timer 3 is used to trigger a fourth off-delay timer, which actually controls cylinder 3. This solution gives about 99% correct behavior, but it's important to note that since timer 3 has to be set just shorter than timer 2, cylinder 3 will extend before cylinder 2 actually raises. This behavior is subtle, but it is undesirable. Now I'm adding my counter because I want my system to only run as many times as I have parts in the magazine and then stop and wait for the magazine to be refilled. Now, notice as I'm running this that it will run exactly 5 times, and then the counter will be expired, and we will have to reset the counter, i.e. refill the magazine, and signal that we've done so before the program will continue. Final stage of our program involves coming up with some way that we can postpone the extension of cylinder 3 until cylinder 2 is completely raised. We'll do this by adding sensor 2S1, which is attached to cylinder 2, the vertical cylinder, to our code, and we will use that to trigger a relay K3, and we'll use the contactor on K3 to break the rung containing the actuator 3M1 so that it cannot fire until cylinder 2 is completely raised. And at long last, I can finally demonstrate the final code to you. Please understand that this video may only be 16 minutes, but this took me a full 4 days, morning until night, to put this all together and to cut it, so please be kind. I appreciate it.